we're going to look at a question involving the application of probability from Unit 4 A2 Mathematics. The question involves a game. The game involves two archers who are going to shoot an arrow at a target alternately. Harry is the first person to play, and then Mary is the second. Mary has a probability of 0.3 of hitting the target, while Harry has a probability of P of hitting the target. What is important here is that successive shots are independent of each other. First, we need the probability that Mary wins the game with her first shot and then her second shot. To do this, we need to consider some of the pure maths from our Unit 3 Pure Maths course. A geometric series, we remember, is one in which each term in the series is obtained by multiplication by a common ratio. The first term is A and R is the common ratio. In this situation, we are able to sum such a series to infinity, providing the common ratio lies between -1 and +1. This will indeed be the case in probability. So let's return to the question and let's have a look at what's the probability that Mary wins the game on her first shot. First, we define our events. Let M be the event that Mary hits, that's probability of M is 0.3, so she misses with a probability of 0.7. H is the event that Harry hits, that's P, and therefore H dash is a probability he does not hit, that's 1 minus P. For Mary to hit with her first shot, since Harry goes first, then Harry must miss, and then Mary must hit. Harry missing, 1 minus P, Mary hitting 0.3, and because these are independent events, we multiply to give 0.31 minus P. For Mary to win on her second shot, we need a complete round of failures. So Harry misses, and then Mary misses. Then Harry misses, and then Mary hits. So we get 1 minus P times 0.7, 1 minus P times 0.3. Put this together, we get 0.21, 1 minus P squared. So this idea that we have a complete round of failures, which if we proceed for Mary to win on her third game, would have 2 rounds of failures, followed by 1 final successful round for Mary. So this is how we can show the probability that Mary wins the game overall is given by this expression. If we consider each time there is a losing round, we get 1 minus P times 0.7, and the final winning round for Mary is 1 minus P times 0.3. Considering that Mary could win on her first, or her second, or her third, or her fourth, or her fifth, etc., 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 to infinity, each time we simply multiply by the common ratio, which is the probability of a complete round of failures, 1 minus P times 0.7. Using the concepts that we understand from pure maths, that the sum to infinity of a geometric series is A over 1 minus R, providing that R lies between -1 and +1. Here our first term is 1 minus P times 0.3, and our common ratio is 1 minus P times 0.7. Substituting these into our sum to infinity formula, manipulating algebraically, expanding the brackets, multiplying numerator and denominator by 10, we obtain the result that we are after. So we conclude that the probability Mary wins is 3 minus 3p over 3 plus 7p. So next we want to find the value of p, such that Mary is more likely to win than Harry is. If this case is such, then Mary's probability of winning must be greater than 0.5. This is because either Mary or Harry wins, and the sum of these probabilities has to be 1. Mary's has to be bigger than Harry's, so therefore greater than 0.5. We know the probability that Mary wins, we've just obtained this, and so giving this the inequality that this is greater than 0.5, and manipulating our inequality, collecting together our like terms, we have 3 over 13 is greater than p, and so p is less than 3 over 13. So this is a really nice example where pure maths and applied maths are linking together to solve problems involving probability.